Hello all and welcome back. So in this video, let us continue our discussion about data structures and now let's learn about linked list. So let's get started. Now linked list is actually a linear data structure just like arrays or list, right? What does that effectively mean is that wherever we are using arrays or list, we can actually use linked list as well. So now before we move forward and I explain you what exactly linked lists are, let us first see what the problem is in arrays, right? Because of which we have to come up with a new data structure that is linked list. So if you remember, right, the very basic array definition, the one which we discussed in the initial module and the one which is there in Java or C++, whenever we define an array, it asks us for a size as well, right? So it asks us for a size and let's say that size can be 3. Now, once you do this, what effectively happens is that in the memory, a space for 3 elements will be created, right? We have already seen this particular working. We have, of course, also used the same for creating our own dynamic list as well, right? So the one question which we did where we created a dynamic list. Now, it's all fine and good till you want to just add 3 elements. The problem occurs when you want to add more than 3 elements, right? Because this particular space, right? This particular space, this might not be mine. This might not be free. Not be free. Now, what used to happen because of this is that if let's say you need to add another element, then of course we will have to create a completely new array with greater capacity. Okay, and then make sure that we copy all the elements there, right? The very similar working actually happens inside a list, which we have already seen. To define an array in Python, okay, the NumPy arrays, which is normally taught as a part of data science stack, that is also on the similar principle, right? So if you that is also a fixed size, okay, so you cannot add any more elements in that the size which has been already been assigned. Now, if that problem will persist, if let's say you create an array of 10 elements tomorrow, then maybe it can happen that I can add 11 elements. For 20 again, I can add 25 elements. So that's not going to cut it, right? If we just make sure that we are increasing the size based on the increased capacity, that's going to be a problem. The second thing which many of you might be thinking, which we can do, is something like this. So let's say I create an array and this time I'm creating it for 10,000 size. Okay. So no worries. You can store as many elements as you like. If you're not using it, all good, right? But there is also one more problem. And that problem is that let's say you have created a very big array. Okay. Now, what if I'm not using the space which you have given me? I'm just using maybe let's say the first 3 elements again. I thought that okay, I might be using 50 or 100 at least, but I'm not using it, right? So all this space here is actually just getting wasted, right? All this is a wasted space. So these are the two major challenges with your array or these string list kind of data structure. So we have already seen about them. So the first one is insert and the second one is memory wastage, right? Now, if we try to understand the basic problem due to which this occur is that in array, your elements are stored continuously, right? So we know that in array, elements are continuously stored. And the same, of course, the understanding will be exactly the same for list as well. Okay, continuously stored. So because of this problem is happening, and linked list is actually now created to tackle this particular problem only. Okay, so linked list help us to tackle this particular problem. The way linked list do that is to by making sure that we can add elements as per our requirement. Okay, so we are not going to make any continuous space. We are not going to save any space or something. Based on our requirement, we are just going to add our elements in the memory. Okay, when element requirements, basic idea of linked list, right? Now, if that is clear, let us see that how linked list does that, what exactly happens is, let's say if you say that you want to add an element, okay, what I'm going to do is I'm going to create an element in the memory, right? Now you say that, hey, I want to add another element. Okay, since I have not stored or saved any space, what I'm going to do here is I'm just going to add another element, but that will not be continuous. It will be stored somewhere else in the memory. Okay, great. If you want to add tomorrow third element, can do that. Will be randomly allocated, not one after the another. Okay. Similarly for fourth element as well, right? Just one thing to note, that all of them are randomly allocated space in memory. Okay, so random allocation happen. They are not one after the another. Now the next big problem which all of you might be able to think in this particular approach is that how would I know that, okay, where my second element is, where my third element is? It's fine that linked lists have created them as per my requirement. It's a good thing that yes, now memory is not getting waste, but how will I access them, right? How do I know that where is my second element, where is my third element? So maybe the one of the approach for that is maybe we can create a array or list to store our addresses. Okay, to store addresses. Now this of course is a very bad way to handle this. The reason is that we were running away from array and list. Okay, but unfortunately we have finally gone full circle and just encountered them again, right? So this is not something which we should do, because again the same problem is going to occur, right? You are going to take an array or list. The second you add more things into that, it's going to create a new copy of itself or something. If you are just keeping very small elements, okay, small number of elements, then of course a lot of memory will gonna get waste. Okay, so with respect to that, what happens is that second approach which I can do is ask my elements to store the address of element after it. So here effectively what I'm doing is I'm asking my element that, hey, can you store the address of next element which is after you? Okay, then the second one I will ask, hey, can you store the address of third element which is after you? So in this way, I'm just asking my these elements that along with the data which you have, please make sure that you are also storing the address. Now, many of you might be thinking that how will that be possible? The idea might be seeming a little bit vague. So let me give you an intuitive example through which it will be clear. Let's assume that say we are in a class, okay, and the class has gone to picnic. Okay, a new teacher comes in and he has having no idea. Okay, he has having no idea that who all students are, and again there are number of children who are playing of the same class. Okay, let's say this is your class. Now you being the first person, what you say is that, hey, I can help you, like you just remember me, okay, and I remember who comes after me. Okay, so what you can do is you say that, hey, you can just remember me, I am the first one, I know who comes after me. Okay, this person will have an idea that, okay, I will ask this person to remember who comes after this person. This person will remember who comes after this, and the last person, he will just remember nothing. Okay, now if you do this thing, don't you feel that now you can actually go to each and every student as well? So let's say if you want to go to the third student, what you can do is you start with the first one, then you go to the second, then you go to the third, right? One more advantage of this is that tomorrow, let's say if you want to add another student, maybe let's say it's from another class, right? What you can do is you can just add him to the end. So you can just ask your last student that, hey, can you please remember this orange person who is from other class? He's going to be after you, right? So in this way, what happens is that you can add or remove student based on your convenience. They are all randomly allocated, so they are not continuous, like they are playing in this big ground. So you don't have to worry. You can still get all the students as long as you remember the first one. Okay. So this first one is actually known as head. And if you will see the way these students are now linked to each other, right? That's the whole idea behind linked list as well. And that is why they are known as linked list. So let me just draw and explain you how it will happen in your overall linked list. So the very first thing to notice, this is, oh my bad, yeah. This is going to be your each element. Okay, so your each element will look something like this. It will have two things. The first is going to be the data which you want to store in it. The second is going to be the address of next. So in computer terms, address is the thing, right, which we have to remember for the next element. Now, if that's the case, what we can do is we can create a single element. Okay, divide it, have it, ask it to have two properties. And now let's say if I add four elements here. Let's say if I'm adding four elements here, all I have to do is, so again, yeah. So let's say these are the four elements. Now all I have to do is I have to ask my first element to, hey, can you please remember this element? And he will be good to remember this. I have to ask my second, hey, can you remember the third one? He will be good to remember this. Third one can again easily remember the fourth one. And this one can just remember that no one is after this, so it is null, right? And I myself can just remember that this is the head pointer or the first pointer. Now you will see that all these elements are linked together with each other. That is why again the name is linked list. And using any of them, like using the head one, okay, if you just remember the head, you can actually go to any of these elements, right? You can ask head, hey, can you tell me who is next after you? And you will reach him. Then again, you can just reach to the second, third one and fourth one. Now the good part, you can actually add even thousand of elements, no space is getting saved. So as per your requirement, you can keep on adding or even removing the elements which as you wish, right? So that's the overall benefit, which was the shortcoming in my array infrastructure. I'm able to actually counter that just by making sure that I am remembering one and I'm able to link my all the elements. So even if they are not continuous, I know that there is a sequence to them, right? There is a sequence to them. And that is why they are still linear in nature, just that they are not stored in a continuous format. Okay. Cool, everyone. So I hope with this overall video, you have gotten a great idea on what linked lists are. Please make sure that you also remember this intuitive example of students. I'm going to use that in solving lots of questions as well. In the next video, we are going to go and implement our own this particular linked list and see that how they are connected. Okay, thank you.